All right, I was going to show you this YouTube video, but I decided against it. I just want to get right into it. I'm going to review some stuff from yesterday, and then I'll get into this new formula that we need radians for. So first question right off the bat, you guys are going to help me out. I'm just going to start calling on people. 2 radians. What quadrant am I in? If I have an angle of 2 radians, what quadrant am I in? Well, I really don't know what the quadrants go by in radians, right? But I do know what the quadrants go by in degrees. So suggestion for me with 2 radians, convert it to degrees. So 2 radians equals how many degrees? That's what I'm looking for. But I use the symbol instead. Huh? How many degrees? That's what I'm looking for. All right. Question, Jeremy?
So 2 radians. So based on the top quiz we just took, we know that 1 radian R equals 16 degrees. So
all right, where's this coming from? Like this is stuff. This is probably stuff you looked up and I never taught. Okay, so let's go with what I taught yesterday. 2 radians. Remember I said 99%, you notice a radian's going to have a pi with it. Here's the other 1%. It doesn't. But look on your formula sheet right now. Here's what I'm going to start calling on people. If this is 2 radians and I got to go to degrees, radians, degrees on my formula sheet. Radians equals degrees. What are you going to tell me to start multiplying by? Lauren, hi. Good morning.
Hi, good morning.
How are you?
I'm pretty good.
I'm doing well too. Thanks for asking.
Good.
Yeah.
You multiply by 180 over pi.
There you go, everyone. 180 over pi. Now, unfortunately, what's not going to cross out? Okay. It won't, that 1% of the time I can't cross out the pi's, but I can go to my calculator, do 2 times 180 over pi. Let me get this beast back out. 2 times fraction template 180 over pi, and about how many degrees am I looking at for 2 radians? 21. Good call. I don't even have my sheet. I'm playing with fire here. Sarah? Come on.
114.6.
Oh, yeah, about 114.6 degrees. I now should be able to tell you what quadrant that's in. 114.6. We're going to be in quadrant 16. Let's go. 9. There we go. Frank, what quadrant am I in? Quadrant 2. There you go. So I just needed to convert to degrees. All right, one more like that. Now I'm at 7 radians. 7 radians. What quadrant am I in? So I'm going to do the same thing. Take 7 radians to degrees. I look at my formula sheet. Are we comfortable on picking which one we need on the formula sheet? Yes. You literally start with what you have on the left with what you need on the right. So look for radians on the left, degrees on the right, still multiplying by 180 over pi. Give you guys a second. That's about how many degrees?
I just said 401.1.
About 401.1 degrees, yep. Now, some of you could maybe just handle 401 and tell me what quadrant. Some of you, like me, maybe prefer it to be between 0 and 360. I work a lot better when I'm between 0 and 360. Some of you may be able to handle 401 as it is. Go ahead. If I'm in the place I'm at, which is I like angles between 0 and 360, what can I do with 401 now? Subtract 360. And that's the same as an angle of 41 degrees. All right, so what quadrant am I in then? Come on now. 1-7. Thanks for the point. I couldn't see the 1-7 right there, Zach, but thanks, Sarah. Quadrant 1, yep. There you go. So that's the power of converting. I don't know much about radians on the graph, but I do know a whole lot about degrees. Questions, comments? Okay, next up. Here's what I want to start getting comfortable with. How many radians in the quadrantal angles? What do I mean by quadrantal angles again? Anybody remember that vocabulary term? Quadrantal angles. Jeremy, go.
90 degrees, 180.
Where those land? Talk to me. Where do they land? Those are quadrantal angles, but where do they land to make it a quadrantal angle? On the axes. They're not in a quadrant, they're on the axes. So what we're going to do right now is 90, 180, 270, 360. What are these quadrantal angles in radians? And I want you not only to become familiar with them, to know them right off the top of your head as we get going on this unit. Anybody remember 360 from yesterday? 2 pi, yes, 2 pi. Now, I want to start thinking about it. We can convert, that's fine, we can convert. How does 360 match up with 180? It's half of it, right? It's half. So take half of 2 pi and you get 1 pi. So 180 is equal to 1 pi. Pi radians, 3.14 radians. All right, I think we can even get away without doing anything with 90. How does 180 and 90 match up? Half. So I won't put 0.5 pi, but I'll put half pi or pi over 2. Okay, pi over 2. And again, if you forget, we know how to convert. Like 270, I don't know how I'm going to pull 270 out now. So I'm going to have to convert it to radians. So look at your formula sheet. Let me call on somebody. What do I multiply 270 by to change it into a radian? Degree on the left, radian on the right. Jeremy, what do I have to multiply by?
Yeah, come on.
I don't want final answers. What do I need to multiply a degree by to turn it into radians?
180. Wait, pi over 180.
Pi over 180. I talked to you guys yesterday. We don't want a decimal on your calculator. So how do I clean it up? I leave what in my answer for radians? The pi in my answer. And I reduce 270 over 180. So I'll give you guys a second. 270 over 180 reduces down to...
3 pi.
All right, no need for me to call on anybody.
3 pi.
I heard you. 3 pi over 2.
And how you can know this is because you see how 360 divided by 4 is 90. So each one is 1/2. So you add 1/2, you get, so
Are you done?
1/2 plus 1/2
Are you done?
is 1.
Are you done?
And then you add 1/2 is 3/2.
Are you done?
1/2 is
I want the last 30 seconds of my life back. People want their oxygen back. Everyone good here? My hope is we don't have to take that long anymore to get those. All right, we'll be using these so much in so many problems that it'll be like, 90 pi over 2, 270, 3 pi over 2. Okay, just some that you're just going to memorize just by doing them so much. All right, so the big topic today is where can I start using this radian stuff? And the answer is in circle problems. All right, stop, Sarah. All right, stop. I saw that face. All right, relax. And it's not going to be that bad. All right, I'll go get back to you at the end of the period. It won't be that bad. Circle problems. All right, problems involving a circle. So what I want to first do is making sure we know the parts of a circle we're going to be working with. All right, so forget this problem right here. Hi, I'm a circle. Right, we're all good? Okay. Anybody know what this part on the circle is on the outside called here? No, not the total. That's the total distance around. What this piece of a circle is called? Arc. Arc, right? That's an arc. Okay, that's an arc. All right, that's an arc. Here's the center. I draw this line segment into any point on the circle. This right here is a what? That's a radius, right? And if I draw another one in, that's another radius. They're both the same length. Any radius I draw in a circle is the same length. All right. And then again, what did you guys call this part right here? That's an arc. All right. So this is the arc length right there. So you got radius, you got arc length, and then does everyone see the angle that I formed when I drew the two radii in? All right. That is going to start being called theta. This is another Greek letter that stands for an angle. Okay, now this would really, really impress me. From your geometry days, you remember what that angle was called? If it's formed by the center of the circle? No, not from your geometry. I know that was a long time ago, right? And to be honest, guys probably didn't even do it because that's when we went out of school. Began with the C, ends in entral angle.
Central.
Thanks, guys. Thanks for humoring me there. Central angle, yeah. That's the angle formed by the two radii. Okay. Using radians, we can find this angle. Okay. Using radians, we can find this angle. So I'm going to come back to number 5 right now. I want to give you the formula we're going to be working with right now. Okay. So if you just flip the page, there's a box at the top. We'll get back to number 5 here in a minute. There's a formula that I'm going to give you, unfortunately, not on the formula sheet. So what am I trying to tell you? It's not on the formula sheet. So, Ryan, what? What's the problem? It's not. I was just holding up yours it's not on the formula sheet. So what am I trying to tell you? Well, know it. Yeah. I don't like the word memorize, but know it. Yeah. Here it is. That relates the central angle, the arc length, and the radius. Ready? It's it's an easy formula. I don't feel bad that you have to know it. The angle, the central angle, theta, is always equal. That angle will always be equal to whatever the arc length is, S, over the radius length, R. So let's do this. Here we go. This is your arc length. This is your radius length. And then theta is your central angle measure. Now, where do the radians come into play? I'll let you guys write that down because this is the biggest part about this formula I'm giving you. Where do radians come into play? This formula can only be used if that central angle is in radians. Okay, in radians. Oh, well, what if it's in degrees? What do you have the ability to do? Convert it over to radians so I can use the formula. Okay, so anytime, here we go. Anytime I given a circle problem, this is the formula I'm using. Okay? The central angle can be found by taking the arc length divided by the radius. Now go back to problem 5. Ready? Radius is 4. Radius is 4 units. The arc length is 8 units. How many radians would that be for that angle? All right, so let's get out the formula. Theta equals S over R. What's the 4 belong to?
The R. Radius.
4 belongs to radius, so it's going to go in for R. What's up, Sarah?
Never mind.
You sure? Go ahead.
I just thought it went into the theta thing. The new stuff.
What's the theta mean? That's my central angle, right? And that's what it's asking me for.
Yeah.
All right, so that's what I'm going to leave blank. The R is 4 because that's my radius length. And now, Sarah, what's the 8?
It's the top one.
That's the arc length, right? So 8 over 4 is the measure of that angle, which would be, okay, talk to me, 2 radians, right? 2, you don't have to write radians, but that's what that means. Because remember, anytime I use the formula, the angle's in radians. So that angle is 2 radians, which we know is something in degrees. It's just another way of measuring an angle. Questions yet? Okay, that's it. That's what I want to work on today is this formula. But giving you different pieces of the formula. Ready to roll. Circle has a radius of 1.7 inches. Find the length of the arc, whose central angle measures 2 radians. Got it. So I see a circle, radius, arc length. I know I got to use my formula. Theta equals S over R. Let's start with the 1.7. Let me call on somebody here. 1.7. Where's that getting plugged into my formula? 20? Sarah?
Yeah, it's gonna get plugged in for R.
Good job. R, 1.7. Where's the 2 radians going to get plugged in for? The angle is 2 radians. What's that going to get plugged in for that? 1, 4, 6. It is. I can see that right in front of you.
The two gets plugged in for the what is it? Circle, the central angle.
Yep. Nate, come on. What's that Greek term called? Come on. I want you to use it.
Theta.
Theta. Good. And it's in or at 2 what? Radians. So I could just plug in 2 because this formula only uses radians. So I can plug in the 2. And what am I solving for? Arc length. S. You can put an X there if you want. I don't care. How do you solve this?
You multiply by 1.7.
You can put the. Some of you feel comfortable putting 2 over 1 and cross multiplying. That's fine. Multiply both sides by 1.7. Yep. S equals 3.4 inches for the arc length. I'll always give you 2 out of the 3 values. I'll always give you 2 out of the 3. You just got to figure out what 2 I gave you.
Would it be possible to solve with 1?
No way. How?
No,
You'd have 2 different variables.
that's true.
Okay. Questions from you guys? Okay. Now what I want to do is put this into a word problem where you got to figure out, wait, that part of the word problem is actually the radius, even though it doesn't say radius. This part's the arc length, even though it doesn't say arc length. Pendulum. Oh boy. Here we go. I do this every year. Pendulum. Anybody? No idea what a pendulum is, you kids?
That's the ball thing where it hits.
Oh, so some of us do know what it is. Yes?
Yes.
Okay, well, I got to do the old images here. There it is, pendulum. Right here, it goes back and forth. Yes?
Yes.
And then you got these cute ones like here, the sun cloud one. See how the cloud's the pendulum was? That's how that goes. All right. Oh, look at that. Got the dinosaur. Clockzilla? Give me a break. Oh my God. The pencil, oh boy. Oh, that's cute. Look at that. The tractor, the excavator.
You should
A little?
put these for your room.
No, absolutely not. Everyone would lose so much respect. Got the owl. Oh, this is one of my favorite, the shark.
So pendulums are arc.
There we go. Got the little fish inside, the 8 going back. $53. Are you kidding me? I would never spend that money. $53. Get out of here. 20 tops. No, these are cute. The animal ones. Nice.
They're 52.
Yeah, $52. I could just pick a student to go and do it in the wood shop for me. $52. Oh, these are nice, huh? So everyone's good. Pendulum. We know what we're talking about here.
I'm in woodworking if you want one.
Oh, hey. Do you think you can hook a guy up with one of these? That'd be... Oh, wow, we got more. Oh, look at that. The crab. The porcupine. I don't know what's going on there. That's disturbing. The dragon spaceship. Wow. Owl. I just think this is going to get weird if I keep going. So, all right. So we know what a pendulum is. It swings through an angle of point. All right. Well, right off the bat, here's my first number. 0.5. It swings through an angle of 0.55 radians. Out of the three values in theta equals S over R, what's this going to be if this is my angle? That's my theta. Can we all agree here? I like going through the problem right now and figuring out what I'm given. So there's my theta. What distance does the tip travel? It has a length of 8 feet. See, this is where it gets confusing now. The pendulum has a length of 8 feet. So would that be my arc length or my radius? As you see the pendulum going back and forth, back and forth.
Radius.
Would the 8 feet, the length of the pendulum, be my radius or my arc length?
Arc
Radius.
What distance does it travel? So here you go. You got your pendulum here, right? Got your pendulum going back and forth. And I want to know what distance does it travel? What am I making right here?
An arc length.
An arc length. That's what I'm solving for, right? The arc length. And what's the pendulum end up being?
8 feet.
Which is my what in the formula?
Radius.
That's my radius. Okay, the length of the pendulum is your radius. How far it travels is your arc length. The angle that it makes is theta. So I'm going to put in 0.55 equals S, which is the arc length I'm trying to find, over the length of the pendulum, which is the radius, 8. Okay? So any pendulum questions we have in the future, the length of the pendulum is your radius. Question?
Do we need to like draw a picture if we got a problem that talks about a pendulum?
What about it?
Do we need to draw a picture for it?
I don't care. Go ahead. I don't grade diagrams, I grade work. So how far does it travel?
4.4.
4.4 feet, because we're in feet. Questions before we get to the last two? Okay, another pendulum one. Now it swings through an angle of 30 degrees. This will be my what?
Theta.
Theta. The tip of the pendulum travels along an arc whose length is 4 pi. What's the 4 pi then? R or S here. Think about it. The pendulum travels through an arc whose length is 4 inches.
So S.
What's 4 pi? R or S?
S.
S. What am I solving for?
R.
Find the length of the pendulum, R. What are you guys plugging in for theta?
30 degrees.
Oh, are you?
We have to convert.
No, I can't. No. I can't use 30 degrees. Why not? What did we say at the beginning? This formula is only if the darn angle's in radians. You cannot plug degrees into the formula. It is only reserved for radians. So off to the side, what do I need to do with 30? Convert the darn thing. All right, let's go. What do I multiply 30 by to convert it to radians? 20. Sarah. Pi over 180. Leave the pi in your answer. 30 over 180. Reduce it. 1 pi over 6. So that is what's going to go in for theta right now. Pi over 6, the radian version. Pi over 6 equals 4 pi over r. All right, let's stop. How do you want to solve this one? This is a new one. How can I solve this one for r? Fraction equal to a fraction, cross, multiply. Pi times r, just pi times r. On the other side, 6 times 4 pi, 24 pi. How do I get r by itself?
Divide by pi.
Get the pi out of there. You can go on your calc if you want, that's fine. Or you can see it right here, what's going to happen.
Let's cancel out.
The pies will go. And the radius length here, 24 inches. Can never plug degrees into this formula. Convert it first. And then our favorite one for some of you from yesterday. What's the positive radian measure of the smaller angle the clock makes at 5 o'clock? So this angle right here. And this isn't theta equals S over, this is nothing. This is just going back to review here. So what's that angle in radians at 5 o'clock? Well, let's forget radians because we can always convert it at the end. Let's go degrees here first. How many degrees between 12 and 5 now? All right, I tried to explain some of it. I went pretty quick yesterday and I wasn't up here explaining it to everybody. If I go all the way around the clock, all the way around, 12 to 12, how many degrees am I going?
360.
Can we agree it's 360, right? 360. And does everyone see it's always broken up 1, 2, 3, 4, 5, all the way up to 12. It's broken up into 12 different sections. So if I take 360, divide it up by 12, that tells me when I go from 12 to 1, 1 to 2, 2 to 3, etc., how many degrees am I going? 30. So as I go from 12 to 1, that's 30 degree movement. As I go from 1 to 2, that's 30 degree movement. So if you add all of them up or multiply, how many degrees is it as I go from 12 to 5? 30 times 5, which is 150 degrees. So that angle right there is 150 degrees as I go from 12 to 5. But I need it in radians. So I'm going to take 150 degrees and convert it. Every time you go 5 minutes on a clock, you go 30 degrees. So you go pi over 180 again. Leave the pi in your answer. 5, 6? 5 pi over 6 radians at 5 o'clock. All right. Delta Math, get a couple problems done before we get out of here. It's all about the circle problems. All about the circle problems.